pockets of nodules, more continuous substrate. And I haven't seen too many critters, but it's brief, maybe just around the corner. We'll see some more.
Ooh.
Comment here saying, yes, everything is pretty well encrusted here.
Nice.
And hi, Dave. Your fan club is cheering for you and hoping for a lot of good zooms.
Why, thank you, everybody. I appreciate
A lot
that.
of avid fans out there.
Yeah, I get called Zoom In Dave. Some pilots just, repeat over and over, Zoom In Dave.
You need a t-shirt.
I'm in his fan club as well.
Oh,
Yeah,
right
I should sell merch, I guess.
We have a Reddit group.
My longtime shipmate, Robert Waters, is
Bob, oh my gosh.
famous for the Zoom In Dave.
Hi from Arizona. I've been watching the Nautilus for a while now. I'm curious as to what column of the ocean you are in. It looks like the twilight zone, but I'm not sure.
We're deep, deep, deep into the abyssal zone. We're at abyssal depths right now, currently at 4,283 meters, and slowly traversing upslope. Thanks for tuning in. It's we're primarily focused on the benthos, so the seafloor habitats and organisms that we're encountering, trying to get some good imagery as we traverse up this hill, this knoll, and then also providing us great imagery of the seafloor context, the geology, so we can better understand the full environment, the whole holistic view. In addition, the Little Herc is collecting water column data, so CTD information, temperature, conductivity, and depth. So again, that provides us additional environmental context, provide us an understanding of what habitats, what organisms may be limited by in terms of temperature and so on. But I'm still struck by how much material I'm seeing in the water column. That definitely has changed as we've been moving. So a little more particulate, suspended material. I can't tell you what it's composed of, but given that we've been seeing animals along the track, those animals, those benthic organisms are feeding off of that.
Yeah, someone says stuff in the water, as in marine snow, is very good. Lots of potential for lots of biology.
That's right. It's the food for the deep sea. These animals can't go out to the grocery store like we can. So they rely on food to be transported to them. And in some cases, they grow really long stalks so they can be perched up above the benthic boundary layer and allow their food tentacles, appendages to capture food. And some animals, like we've been seeing with the sea cucumbers, are like vacuum cleaners of the deep. They are just hoovering the seafloor, sucking up, selectively feeding on that soft material that is deposited on the seafloor, and it's organic rich. They're highly selective for that. This is way below the euphotic zone, so they are not reliant on sunlight for their food, but the food is produced in the water column in the surface ocean and then is transported to the deep over time and transported to these environments through currents as well as natural deposition.
You can come down a little
The
bit.
terrain has really changed.
No. Okay,
Where
and
did
then
all the
get ahead of you.
nodules go, Rima?
I'm looking for where the sponges went.
You miss your sponges now.
Somebody says, actually, I guess Rima was not a fan of SpongeBob.
Oh no, she can't say that.
I did like Patrick Star though.
Patrick, yeah.
Yeah.
Wow, Patrick's funny.
Huh. We have another comment saying, it seems all this is like likes or ridge-like formations on the ground. Here is just some worn down basalts in some places. We can still see the pillow shapes. Good observation. Yeah, there's a bit less sea life over here.
Where did they all go? I don't know. Something about this environment is less hospitable to the organisms that we were seeing earlier on in the dive. Maybe food availability or the currents. I don't know.
Oh, there's some tracks there.
There are some tracks.
Kind of, I'm going to try and get more behind the vessel, which will be more to my port side.
Yeah, the
Okay.
seafloor does kind of have that kind of worn texture to it. It doesn't look as, smooth and rounded like those pillow lavas did down slope. So I can see that comment from your observer. Yeah, that makes sense.
We have another comment. May be more in the lee of the main current, but we also aren't looking closely as we are way higher up fighting the tether. I don't see any sponges over here.
Let's see.
Seem to be going down a little bit here.
Yeah,
too.
I guess the ROV pilot heard you.
He's
He's just setting down a little bit.
Closer.
We're about 2 meters off bottom. The team is trying to navigate the slope carefully, along with stepping out the ship in a way that allows us to make way in a careful manner.
So what are those tracks from?
Yeah, it's a good question. I think we had some debate about that earlier.
It's a sponge. Another sponge.
Oh man, I hope someone recorded that. That's for the records. Yeah, I think there's speculation about what may be making those tracks. Definitely animal of some sort. There have been a lot of sea cucumbers or hollothurians observed throughout the dive, and they make characteristic tracks and leave their fecal piles behind, their poop piles. There are also other organisms, different kinds of sea stars, as well as mollusks, gastropods that could make tracks like that. However, we haven't seen any gastropods as of yet. They may be super tiny, so we couldn't observe them.
What's that right there? I see a little white
Yeah, there's something white in front of us.
snail or... Wow.
Yeah, super steep.
Yeah, this is gonna keep going. Yeah. So So we're just going to keep dropping here.
Yeah, if you look.
Yeah.
Yeah, so we're traversing up a very steep slope, and
We're
it'll be
going
going
down
for quite a
slope
bit.
now. Turn off that auto altitude, that's not helping.
Somebody's asking, is the heave, pitch, and roll data in meters? I would assume yes, because everything else is in meters, but I'd rather be sure.
Yes, everything's in meters.
All right, we have Maddie here. She's going to take over for me while I go eat some dinner, but I'll be right back.
And we're swapping out video for a quick dinner break.
Some watch changes so people can have their dinner, very important. And
I'm going to try and get
yeah, we're going to
back
sneak up around this
more behind
steep
the vessel
feature.
here.
I guess we may
So
be heading up and downhill
yeah.
throughout the dive
So I'm going to try and
to
change my head
try
in
to get
that
a
way
better
bit.
understanding of these
Head
this
off that way.
knoll this knoll complex. The complex is a series of hills, and they have kind of these dimple shapes in them, little what look like big pits.
Yeah, I was going to say, you see that? Okay.
We're using a variety of different technologies to better navigate along the seafloor, since it's hard to see what's up ahead with the lights we have. So we have a scanning sonar that the team is looking at, basically seeing if there are any obstructions in our way up ahead. We're currently in the water column right now, just about 15 meters off bottom as we traverse to a better spot on our dive track. And we've seen a lot of interesting critters on this dive so far. Several different kinds of sea cucumbers, corals, sponges, fish, and at least a few sea star varieties and brittle stars. And a lot of different
My
rock
lateral
types.
isn't working
So
very well.
habitats have been changing throughout the course of the dive. And what other animals have I forgotten?
I think you got them all.
Got them all?
Yeah.
Okay.
Don't
Why not?
forget the sponges.
Yeah, lots of sponges. Yeah, there was a variety. So we had glass sponges and these carnivorous sponges as well. So sponges that eat little critters.
Not to brag, but we did see a ctenophore on the 12 to 4 watch.
About the ctenophore. How could I forget about the
I
ctenophore?
also saw it in the lounge.
we all experienced that. We were
But
maybe
that
with
has
you.
been my favorite.
Yeah, that was
so
cool.
That was really incredible.
That was really cool. Sorry to drop in that
No, you're
that
good.
subtle like one up. The faceless eels were pretty cool too.
Oh,
Those
yeah.
were really, really cool.
That was wild. The one kind of cusk eel that is blind,
Yeah.
but
Yeah.
I'm going
the
down.
eyes are
I'm
like
going deeper
grown
now,
over with tissue, I guess. So they're vestigial. They're no longer of use to the fish, but they retain them. A lot of really great information coming in from our scientists on shore who've been tuning in and watching. It's a really rare occasion for us to dive at these depths and anywhere, let alone in the Pacific Ocean. So people are very, very interested in what we get to see and encounter. Every observation is something interesting, and in many cases something new. We haven't ever been to this spot on the seafloor before.
You know, somebody said in the chat earlier, we always say this is the first time we've got eyes on the seafloor, and somebody in the chat earlier said, and it's probably going to be the last time. And I was like, oh, I've never
no.
thought about it like that. Like, we don't really return to the same places all that often.
You never
Really?
know. A
You
lot of
never know.
these expeditions have inspired future work. And I know when I came on the Nautilus in my first year sailing on the Nautilus in 2013, the work that we did off Puerto Rico inspired a proposal and a project that then yielded a follow-up expedition in 2014. So it just depends. It depends on the questions and those scientists involved who are participating now, inspired to learn more about those environments, and then obviously getting the support to come back and do the work and the right kinds of assets, right, Rima?
Well, fingers crossed that this isn't the last time we're here.
Yeah, agreed.
We had somebody ask, we're doing our dinner relief right now, so some of the 12 to 4 is coming in to let off the 4 to 8 watch so they can go eat. And someone asked, are there any remarkable dinner options tonight? And I'm so sorry, I didn't even look at the dinner.
You didn't?
No, I saw the curtain go up and I was like, I gotta go get Kahena. And then but so you guys will have to ask, you'll have to report back after dinner.
We'll do.
What you all had. Remarkable dinner.
We've had lots of varieties of food choices on this expedition. It's been wonderful. And snacks. Afternoon snacks.
Can never go wrong with cake at 3 p.m.
And you do not starve on boats, that's for sure.
No.
So with that little sojourn, we just traversed a wee bit, and now we're back in nodule land.
Wow, look at
this is crazy.
This is like deja vu, isn't it, Jaina? We were just here 6 hours ago.
Different stitch of seafloor, but looks a lot like, what you guys encountered earlier.
Yeah, this is looking more like the typical nodule field that you find in our central area.
Nice.
Small spherical nodules. So, wow.
Are we on kind of a shelf here, or?
We are currently heading upslope
Okay.
on this peak that we're heading towards.
So we're approximately 1.3 meters off the seabed here now.
Okay.
Amanda, we have a question too. Well, they want to know, are these nodules kind of cemented or connected to the bottom of the seafloor?
Oh, that's a great question. In some cases where we were traversing the seafloor, we observed the nodules really cemented in place. And then, but what we're seeing here, these look a little looser. So I think that that varies throughout the course of the dive and throughout different areas. In some cases like this, we see the nodules are looser. These might be easier to pick up, for instance, if we were able to sample. But in earlier part of our dive on our watch, we saw the nodules, what looked like they were cemented in place, encrusted, and would be really difficult to collect. So it varies.
Yeah, these are really great questions. Somebody else wants to know if the nodules are more concentrated at the bottom of the slopes or more evenly distributed. And we've certainly, over the course of this dive, seen a lot of variety, right?
For sure, yeah. It's actually been really incredible. I've never been to these depths not in nodule environments before with an ROV, so this is a brand new world for me. But I am just completely struck by the variation, as you say, Maddie. We've seen lots and lots of clusters of nodules, piled on top of each other, it appears like, and then in some places they're sort of spread out. And in other areas, we'll see what look like, pillow lava with sort of depressions, and they've accumulated in those cracks and crevices or valleys. So a lot of variation throughout the dives. And this one stitch of area within the Cook Islands, so it's amazing. The heterogeneity.
Exactly.
Yeah.
It was definitely surprising to me
Yeah.
to see all the variety in the rock formations. Sometimes you think, oh, it's abyssal plain, it's all the same, but that's clearly not the case. It's really cool to be able to see that firsthand.
And then as another additional observation throughout the dive, we've seen a variety of different animals that are either attached or moving along the seafloor, demersal fish that are tightly associated with the seafloor, sea bottom. And they've varied in abundance, and we're only just beginning to understand what their habitat association is here.
Yeah.
But the information that we're gathering on these dives will help provide us a better understanding of their distribution in space, and again, providing us a window into future studies and future questions and hopefully more research.
And somebody just shared a comment about these sediment deposits that we're seeing on top of the nodules. And in addition to those sort of darker black lines, those are paths of hollothurians, or sea cucumbers, that have sort of scooted along the seafloor. And then are those deposits of sediment, is that the sea cucumber poo? Is that what we're looking at?
In some cases, I'm seeing that, accumulation of what looks like sort of coiled, coiled material, coiled poop. In others, there may be just simply accumulation of sediment in that little crevice. So if there's a depression on the seafloor, a little pocket, then material raining out from the water column will collect in those depressions and pits.
Does that imply that the...
Oh, look at that.
Oh, there's a little
Little
squiggly.
squirmy guy.
It's just there and gone.
What?
It heard that there was dinner too.
He's hungry.
Not enough food for everybody.
Oh, here's a great question too. Does the composition of metals within the nodules vary by location, or are they pretty consistent?
I would guess that they do differ by location, just because there may be different like outcrops of magma flow. Like there could be different volcanic, I don't know what the correct word would be, but they're certainly not a homogeneous substrate across the entire floor. You have different types of mountains on land, so it makes sense that there's different types of mountains and substrate beneath the ocean as well. Maybe others are more rich in sulfur or iron or cobalt or manganese. Certainly we've seen variations in manganese on the rocks themselves as we've been swimming through, but that would make sense to me.
Hi, Sandy. Good to see you again.
Hey, how's it going?
Good. It's like we were just here.
Deja vu.
Deja vu.
Never even left.
Well, we have left because the ROV is at a different depth. So I think when we left, it was about 4,500 meters, and we are now at 4,299. I think we started the dive, Amanda, like 4,800. Is that about right?
I think I left, it was like
that sounds about right.
4,400.
44, yeah.
But we were definitely deeper before.
Yeah, we started the dive, I think, at about 47, 48. So definitely gaining some elevation.
It's interesting the terrain has sort of changed in terms of the rock sizes. So there's like, earlier there was sort of similar size nodules, and now we're in a different part of the feature. And we're seeing a lot of,
Move down a bit.
say like rocks that are big and small, a little more varied. Don't know if those are coming from upslope, if they were like eroded away and then are falling down slope, or what their origin is.
Oh, interesting. Yeah, and then we had those basalt pillows too, which were really fluffy and cool
Yeah.
looking. And
Looks
there's
like
a
something
big
big
rock.
up there,
Yeah.
yeah.
And then we had that almost that shelf-like feature as well.
Yeah, the crust.
Yeah,
the
that's
crust,
really
thank
cool.
you,
those
yeah.
ledges.
Yeah.
Those are neat.
Really, really cool.
Who would have thought it would be so interesting?
I bet you a geologist thought about
I
this.
know,
I bet you a geologist named
Definitely.
John too.
Maybe.
Oh,
Very
speak of the
possible.
devil.
Speak of the devil.
There it is.
Oh.
All right.
We're reuniting. How much I
think
missed the 12 to 4.
John is here, and he can tell us all about dinner.
Yeah.
No.
Oh, John can also answer that question about the different chemical compositions of the rocks.
Oh yeah.
More than I probably could.
Oh, big rock.
Oh,
Big
wow.
rock.
Big dark rock.
Yeah, big dark rock. Hey, ROV pilots, how are you? We have a
All
question.
good.
Good. I'm glad you're
Yes.
good. What is it like controlling the ROV? And what kind of training is needed to become an ROV pilot?
That answer can vary quite a bit. So the training is typically you take electrical or electronics or kind of mechanical engineering type courses, and then you just pursue it. There are some ROV schools, but generally people get hired from having like a marine background and electrical engineering and or mechanical engineering. And the first part of the question I glanced over. What was the first part again?
Oh yeah. What's it like controlling an ROV? Oh, sponge.
They vary quite a bit from machine to machine, but generally you want to keep kind of slow, steady movements. If you
It's a sponge there.
try to put too much power into it, you end up moving the machine side to side too much when they're trying to focus on things and zoom in. And you drift up off of it. Yeah, like now.
Like now. Case in point.
I'll get back up to that. Yeah, you just want to be calm and steady, kind of slow movements.
Do you do a lot of breath work or meditation in your off time?
No, but I probably should. There you go, Dave, if you want to zoom in on that.
Yeah, please.
And then we'll have to get moving again.
Okay, sure.
So it'll be a quick zoom.
Definitely a cute little sponge squat on the bottom there. Let's see if we can get a little idea of that.
Interesting that there's no stalk on there.
Yeah, some of them...
It's different than what we've been seeing.
I guess sometimes it's advantageous for the sponges to be higher in the water column to maybe intercept more of the particulate matter in a current, and sometimes they've adapted to just collect on the ground.
Okay,
But
and if you
there's
zoom
huge
out,
variety
I'll get moving again.
Morphology.
And you can see these ones are bigger and wider, so they probably wouldn't do too well on a stalk, would they?
Yeah, true.
So maybe by being wider, they've got a slightly,
I think
process
it's
more water.
still a
Can you
Hyalonema
zoom out
sponge.
fully?
That's an interesting rock. Look
Yeah.
how there's a hanging
That's full
there.
zoom.
Okay.
Right?
It's
I-
a
just
pillow,
really
yeah.
close.
It's a pillow that's come
Thank
out and still welded in place out
Wow.
of the lobate next to it. And you can see how the bottom of the manganese is still dark. It doesn't get covered in sediment like the top.
Oh, what was that question that I just stumbled through answered not too long ago? I think John would know.
Yeah, do the composition of metals within the nodules vary by location, or are they pretty consistent?
They do vary by location, but when we talk about location, we're talking hundreds of kilometers, if not thousands of kilometers, before you see a material variation. So within the Cook Islands, this central part of the Cook Islands, on this particular depth, they're very, very consistent.
Okay,
We have
cool.
a high iron cobalt rare earth type. But if you jump a few thousand kilometres to the northeast, you'll go to another place called the Clarion-Clipperton Zone.
All
And
right.
they're the totally different chemistry. Yeah.
Very cool.
Okay, well, thanks for the cameo, everyone. I'm handing it back over to Kahana.
See you later, Maddie.
Yeah, I'll see you all at midnight.
Yeah,
Okay.
I'll be there.
Or at the dinner table in like 5. All right, bye.
See you.
And so the composition is generally iron, cobalt, is there manganese as well?
Yeah.
Yeah, there's these particular ones are running about 15 or 18%, 70% manganese and about 15% iron. So a little bit, almost 1-to-1.
Okay.
And about the same in silicon. And the manganese and the iron form these layers, minerals called phyllomanganates, or there's an iron version called, it's like little platelets of iron oxides. And then the other metals all kind of fit in. Atomically, these are a bit like sponges.
Oh.
And so the metals
Cool.
slot in between the layers. And so there's some difference between the amount of iron and manganese you get, but the big thing is the other available metals. So at this water depth, you tend to find more cobalt and rare earths are available, but if you're a bit shallower, especially if you're just below the thing I was talking about before, the lysocline,
Yeah.
then you get a nickel and copper can come in as well.
Very
so,
nice.
So it's, yeah, your metals basket, as we call it, just varies between places.
It's that little spot right there. I think that's a sponge. Looks like a sponge to me.
Yeah, that one there.
Yeah. Another Hyalonema sponge.
Maybe
Squat
after
along
that.
the...
And is that, was that
Yeah, you can
look at
zoom
as
in,
well?
please.
Yeah.
Hmm? Oh, I'm not sure. Yeah, pretty little sponge.
You got a snap of it. Yeah.
Nice.
If we zoom it back out, maybe we can look at that feature on the right-hand side. I'm not sure if it's
Sure.
real.
We can come wide, please.
And those little holes in the center are the osculum of the sponge, so that's
Where was it?
where a lot of the water funnels in and out. And the choanocytes, the interior of the sponge tissue, whirls its little tails around and creates that current.
Can you
So
point out
the-
what you were looking at?
I think it's that thing there. I'm not sure
Okay.
if it's, it might just be a bit of dust and odd-shaped rock. Let's start looking.
Yeah, we'll zoom in, please.
Yeah, no, I don't think I'd worry
No?
about that.
Okay,
It's all
we'll
good.
come wide.
It's a bit of ferromanganese. It's like a little nodule on some mud. You do get these irregular kind of nodules. Some of the workers call them popcorn nodules because they look like bits of popcorn. Another small sponge.
Kahana here, I'm back, and that is a great point. It does look like popcorn.
Yeah.
Yeah.
Moving this closer.
I doubt that it
Big
tastes
one.
as good.
You never know.
Oh, we've got some back in the office. We go back if you like, or dig it out.
I'd love
Chew on some rocks.
Is it caramel coated though? Caramel flavor?
As
As a
I was, oh,
geologist,
look at
you
that.
never really
That's
know
Oh,
what's
stunning.
going on until you
wow.
taste it.
Yeah, no, I don't recommend
Ooh,
you
look at
ingest these
that.
metals.
Is that a basket star?
I don't know, it's a
Or-
different color, isn't it?
Yeah, it is a different color, isn't
We'll
it?
zoom in, please.
Yeah, please, that'd be great. Definitely some sort of echinoderm.
That's
Um,
huge.
Yeah, it is big. Wow.
And you see there's a
I would
couple of,
wager,
you see that one and that one there? A couple
yeah.
of amphipods. I don't know if it's caught them.
Cool.
Is that what they are? I think they are. Yep.
Yes, these are passive filter feeders.
Okay, so he's just hitching a ride.
Beautiful. And some of these guys can actually swim through the water column, and others are
Okay, we'll
completely
come wide, please.
sessile throughout their whole life. Some of them can swim when they're juveniles, and then they settle down onto substrate. But I'm not too sure about this one specifically, but it is a great, beautiful visual there.
What are they called?
These
Sandra?
are crinoids, so they're
Crinoids.
basket stars. And they're very curly and flowy and pretty.
Awesome. Somebody said that looks almost like a super pale urchin.
Yeah, they actually are in the same same phylum, so they're related to each other. It's a good observation from that viewer, whoever you are.
We have some ROV questions.
Sponge
How
on the
close to
left.
the max depth capacity will you have the ROVs go?
I'm not sure what the planned max depth is going to be. At the moment, we're at 4,200 meters. The maximum depth of this system we're running right now is 6,000 meters. I'm not sure if we'll get quite that
There's a
deep,
little
but
sponge there.
Yeah.
we'll see how we go over the next couple of weeks.
Awesome.
Yeah, we're hoping to get closer to about 5,000 meters on some of the dives. So maybe 5.1 or 5.2.
Zoom in, please.
Yeah, zoom in on that little sponge, dude. On a stalk. Ah, very cool.
That's a great camera. Look at that.
Yeah, another Hyalonema sponge there for you. And that's just the genus. I'm not sure exactly what the species
Okay, we'll come wide.
level identification would be.
Gotta pick up and go a little bit here.
Sure, sure.
Another question. When seabed nodules are gathered as a metal resource, are they scooped up by an ROV or with something like a dredge?
Generally, there's a whole range of different technologies people are considering.
20
Some-
on Atalanta and 5 right now.
Not many of them using mechanical means because this is not a place that would be shortlisted, I think, for nodule extraction. It's just too rugged and it would be too slow to try and pull the nodules out between the rocks. But on the plains, like where we started this
I think it's
dive,
just a pretty steady
a
slope
much
right
bigger
now.
version of those that might be more prioritized. And then a mechanical device, they're in mud, and so mechanical devices tend to get clogged up with mud pretty quickly. So there's usually a preference to use a hydraulic or electrohydraulic collector where you squirt water, loosen them up, and then suck them up like that. Those can be mounted on anything, track-mounted vehicles, or there is a Chinese technology out there, which is on an ROV that's floating above the seabed. The issue of using a floating vehicle, I'm sure our pilots can attest, is that if you're picking up things, it makes the vehicle heavier. So if you start picking up lots of things, you've got to transfer it very quickly somewhere else. Otherwise, you'll sink your ROV into the seabed pretty quickly. But I think people will just keep developing different ideas and over time. It's very early days, really. A few things have been tested, but we've got a lot to learn, I think, about what the best way forward will be. And usually that'll be a trade-off between production rate, cost of operating and building it, and not least environmental impact. So if you've got a technology that's got a lighter environmental footprint, I think a lot of people look very seriously at that.
Wow, look at those.
Those patterns, yeah. We're still not really sure what makes them. There was an asteroid on one, but often there's nothing.
We had two people commenting that the stream broke. The satellite feed for YouTube is down. Not sure if that was fixed or not, but...
That happens on shore. We generally don't have any control over that, but we'll see if we can get data engineering alerted to that.
All right.
There you go, Rima, another sponge, one of your favorites.
Yeah. Is it another glass sponge?
Yeah, I think if they're white and they're this deep, that's generally what they are. There's a little amphipod swimming away from you as well.
A little hot on the MXD there, Dave. Thank you.
suppose this is a waste of time. Can we double check that both those lasers, or that one laser's still out? Yeah, okay.
No, there's two lasers there.
Look at this. This is a self-healing ROV.
The boys are back.
Yeah.
Preference for them on.
Oh, what's that on the left, please? Yeah. That looks different.
Ooh. What is that, Amanda?
I wish I could reply on her behalf. She's having her dinner. But, I guess is that an anenome? Sorry guys, there's no biologists on the table right now. There's
there's
little
two.
Sponge. Yes, a little sponge, and that looks exceptional. Let's see if we can zoom in, please, and try and get something high quality for our atlas.
Anemone.
Just put that in with a question mark, I guess.
Ooh. That's really big.
Zoom in, please.
Wow.
Man, top looks a bit like a hollothurian, but yeah, that base is definitely. That's a great picture. Thanks, guys.
Yeah, do you want a laser off shot?
Oh, yeah,
Oh,
sure.
yes, please.
Can't really see
Nice.
the lasers too much. Beautiful.
Sorry, I took about 8 screen captures.
That's okay.
Have we seen any of these today yet?
Now he's just showing off with his. I'm impressed. That's just
The
great.
focus
The
resolution.
Yeah,
Great.
yeah,
Okay,
yeah.
we'll come wide, please.
Looks like one laser's weaker than the other. Is it gone now?
No, they're both still there, but yeah, the port one looks a little weaker. I still see the dot though.
Yeah.
So what's the coolest thing you've seen today, John?
Oh, that crust. There was a crust we came up that was on top of the mud, and there were pieces down the bottom of the hill. We came up, and then we actually saw it protruding, and there were some bits that were vertical. I don't know if they'd just fallen that way, which seems almost impossible, or there were like roots coming up into it. Crust can do some pretty strange things in the sediment.
Yes.
The Japanese people sampled them, and they often would punch through a crust with a gravity core and find mud underneath them as well. So, yeah.
Somebody was asking on one of the live interactions whether or not there's any plants on the seafloor.
No, plants generally need light. Well, plants always need light, so there's no plants. There's no flora down there. There is either it's all animals or bacteria, things like that. But the other thing that you do get is a fungi. There's one, I think it's a genus of fungi, a very small fungi that we do see down here. Oh, look at that.
Fish?
One of those fish, yeah.
Quick zoom in, Dave.
And yeah, I don't think you'd see it with the ROV,
Then I'll
but
get going.
people have sampled them in the past. There you go. It's one of those grey-faced fish, we call them. Sorry.
Okay, we'll come wide. I gotta carry on up the hill here.
Yeah, that's fine. We've noted it, and we've taken better photos of it before.
Seems like YouTube is back.
Yeah.
Welcome back. Yay, you're back. We missed a few minutes there, said some people.
Got a stem there on the right-hand side, rims.
Yep.
Yep.
Was that a... Yeah, while you all were gone, we saw some giant whales. We
Good.
saw some
Giant whales, that's excellent. But were they lounging
giant
about?
squids.
Oh, well, they were playing
All
chess
sorts
with
of
the squid.
things.
I'm
That's
sure.
what happens when YouTube is gone for 3 minutes.
Yeah, I believe it. I understand they really enjoy a competitive game of chess at these depths.
Oh, somebody said, I wouldn't mind hearing the rest of the explanation John gave about the variety of metals and nodules.
Oh,
I
sure.
heard to the point he said this area has more cobalt. What were the elements in the other sites?
Yeah, this site here's got cobalt, it's got rare earth elements, so dysprosium and cerium and all the things that we use in transistors.
Is it a star? Oh, it's okay, we've gone past. Oh.
And there's a place called the Clarion-Clipperton Zone, which was discovered in the late 1960s, and a lot of work was done in the 70s, midway between Hawaii and Mexico. The sediment there's more transitionary between silicious kind of clays, like we're looking at here, and a calcareous clay ooze, including a lot more biogenic material. And so it looks like the sediments are breaking down. They're deep enough that the acid, the CO2 in the water is starting to break them down. And that particular deposit has a lot of nickel and copper and a bit more manganese in the nodules there. So that's an area with a lot of focus right now from various parts of the world, and it's managed by a division of the United Nations, and in parallel NOAA have also got a licensing regime as well under it. So yeah, if you Google nodules, it'll probably tell you a lot more about some of the controversy and action happening there. So that's kind of the two main metal types, but even in the Cook Islands, in different parts of the Cook Islands, we see small differences in chemistry. The amount of cobalt, for example, varies. We've got places where it's 0.6% and places where it's about 0.3, which doesn't sound like a lot if you're looking at points of a percent, but it's about 100% difference. So, and we think that's due to slight differences in ocean chemistry there as well. Then there's been nodules found even in the Great Lakes, the Gulf of Bosnia, up near between Sweden and Finland.
What's that?
And the Baltic Sea, and they've all got different chemistry again. Those ones have a lot more silica and even aluminum in them, because there's a lot more terrestrial input into their formation from nearby sediments. Where we are in the Cook Islands is got really low sedimentation rates. We're above us, above the ROV, and the ship is floating in something called an ultra-oligotrophic gyre. It's a place where there's so little iron fertilization from dust. Very little dust comes from the continents. Very little iron fertilization for plankton. Very blue waters, and very, very little sediment makes it to the seabed. So some of the lowest sedimentation around. There's other places in the South Pacific and a place in the North Pacific with the same conditions, but it's definitely not super common. So that reflects, I think, in the quantity and the kind of metal in the nodules we get here. There's just less things to dilute what they're accumulating.
Yeah, somebody said, thank you. I appreciate you rehashing that chemistry as the video feed cut out. Smiley face.
Oh, it's a pleasure. If you want to know more about it, just reach out by email, and we've got a couple of reports that might help discuss it in a bit more detail.
We have another question. Is there more diversity in regions of abyssal plains with larger geological features? And if not, how is biodiversity correlated with the environment?
Yeah, that's exactly what we're out here to try and find out. Yeah, yeah. Yeah, I mean, the general position, of course, is, you can see for yourself, is biodiversity is really low. A little sponge there, Emma. But biodiversity is supposed to be extremely high, and you can kind of count the new things you see, and for a while there we keep seeing the same ones, and then a totally new one will top up. So that just keeps showing us that the further we go, the more new things we see. Oh, look at that! There's another one.
Wow, that's an amazing view.
Looking straight at you.
Woohoo!
Yeah. So it's interesting. You see, we've seen two of these together, and I don't know if it's related to the conditions where we are right now, or if there was a spawning event and a few of them just settled here. So it's never as simple as one causes the other. Yeah. But one of the things we want to take away from this cruise is a more profound understanding on what the biodiversity on this knoll is versus what's the biodiversity we're going to find on the abyssal plains nearby. And we're not going to really know until we finish all of the surveys and then have experts go back through the video footage following the leads that our loggers are finding for them. And hopefully we get enough observations. We really need hundreds of observations, if not thousands, to start to be able to compare and contrast the different areas. It's been a burning question, I know in my mind, and I'm sure in the mind of a lot of scientists, is how does substrate relate to biodiversity, relate to habitat type? Because that goes to the heart of what's called marine spatial management. And we're within a multi-use park called the Marae Moana. It's called the Marae Moana, which means sacred ocean in Cook Islands Maori, and everything in that park needs to be protected or conserved. And you really don't have a hope of conserving things if you don't understand them to begin with. So we're trying to get science from wherever we can to build up our knowledge to help us make the right decisions. And there's no doubt that this particular cruise is a really welcome step forward for the Cook Islanders involved and for the science that we need to back up our marine spatial planning in the future.
Yeah, we have a comment from Lisa. Yes, there's a bunch of tiny animals you aren't seeing.
Yeah, there's 4 classes of animals generally used. You see that swimmer there, eh? It's a little decapod, I think.
Where? Oh, yeah.
Oh, yeah. I'm looking in there. Sorry, Lisa, I'll get back to you on that.
What is that?
I'm not sure.
Not a polychete?
It looks... Well, just flag it, and I guess someone will have a look later. It's so small.
Shrimp, maybe?
It could be shrimp, yeah. Decapod.
All right, Dave,
shrimp.
let's give it a shot. Let's zoom in.
So there's when you come into deep sea fauna, there's 4
That's okay.
All right.
4 size
Maybe
classes.
next time.
Lisa.
Oh, well.
I think that one got away. So we call them microfauna, meiofauna, macrofauna, and megafauna. And the way you study each of those is really different. That's really why the size classes exist. So this kind of towed video is really good for megafauna, which down here is greater than 2 centimeters. So if you're thinking about elephants and whales, they're included, but we go down to 2 centimeters. And this camera is so fantastic. We see even much smaller than 2 centimeters. There you're entering the realm of a size class called macrofauna, and normally to get an accurate view of macrofauna, which goes down to 0.5 millimeter.
Coral?
You need to take physical samples, usually with a box corer, or I don't know what you'd use here.
Yeah.
So, and then below the macrofauna, you go to an animal size class from 0.5 millimeter down to
Zoom in,
32
please.
microns called meiofauna.
Yes, please.
And you need a different sampling technique again, which is usually coring, multi-coring, or just push coring, which Hercules can do, but Little Herc can't do. And then last but not least, of course, we have our microfauna, which are bacteria and archaea, really small organisms below 32 microns. And those are so common and so abundant that any kind of sediment sample will normally give you a pretty good clue of what's around in the region. And for that, we often use, we rely mostly on mass DNA sequencing, like environmental DNA. Anyway, I'm going to sign off now because Amanda's back. And
Thank you, John.
and thanks for your patience.
Thanks for all of your input. See you, John.
See you, mate.
I thought chasing focus in HD was hard. Chasing focus in
Well, it's
UHD.
And I thought
It's
trying to
difficult.
hold the vehicle still with Herc was hard. This is next level.
Yep.
See you.
I might, if I can get far enough ahead, I might try a bit of a sit down if I can manage
Somebody
it
asked
quick
what
enough and
time
then
is it
make
for us
stable
right
and
now?
Zoom in on something.
Yeah, okay.
It's 5:40 p.m.
Gotta get trucking up the hill here. Back ahead.
It's dinner time.
We have about 3 more hours until the next people come rolling in.
We,
2.
Yeah,
Oh, yeah, we
finish,
started
we
at
finish
4.
up at 8. Yep.
Wow. Time flies when you're having fun.
That's right.
I was just saying that.
I gotta say,
What?
I'm a fan of the grilled cheese. I don't think I've tasted grilled cheese that good.
I had that for dinner as well.
Yeah, that was really nice.
What are these white?
I
Oh,
don't know.
wow,
I was wondering if we could
areas.
get a closer look at those sort of lighter patches, pilot.
Absolutely.
That'd be great.
Okay, we'll zoom in, please.
Oh, it's poop.
It
Oh.
does look like it could be poop. Yeah.
Yeah.
Little
Maybe.
bits of sediment, maybe? Well, I don't know.
It's definitely a lighter color
Or
than the surrounding.
Oh, I'm gonna
Interesting.
Looks like
kinda
bird poop
drift
to
up a
me.
little bit here.
well,
Those marine
something
birds, underwater birds.
shady. Yeah.
Yeah, I think it's just spaces where the sediment's showing
Yeah.
through.
Oh yeah, there's
Sheila,
just
come
some
on, please.
sand
Wonder if,
patches.
yeah, if the nodules get disturbed or just through gravity, they get moved and then reveal the sediment underneath. Good point, Dave.
Well, we're down slope, right? So things come loose.
Yep.
Ah.
Somebody
Wow.
said that was a primnoid octa-coral whip.
Crinoid, who said that? Oh, good. Yep, so it's a type of octa-coral primnoid. Primnoid. Primnoideae, those octa-corals have really scaly polyps. So if we were to get a super duper closer look at them, you could see like those little scales overlapping. And they make the surface of the tentacle or the polyps look really rough. They're also making a living off of the particulate organic matter, the food that's raining out from the water column, wafting past them through currents. That marine snow. Make a living off of snow falling from the water.
Somebody asked if we're heading back up kind of to the right where the ridge was. They're asking if there's more life over there. Where are we heading?
Where are we going, Nav?
Where
You've
are
got
we
the
going?
map.
We are going upslope, more or less due east here.
Upslope.
Our
Upslope.
next waypoint is about half a kilometer away, and we're going to gain about 120, 150 meters in elevation on our way.
Somebody asked, are you controlling the ROV?
I'm controlling the RV.
Trying
so
to.
is TJ, yeah.
I don't know if that's backseat driving, sorry. we aren't, but the pilots are.
We have it's a two-body RV system, so we have two pilots, one for Little Herc and one for Atalanta. And yes, we have full control for the most part.
If you look at satellite feed 3 in the upper left-hand corner, you'll see the front row, and you can see our navigator.
Let's zoom in, please.
You can see our two pilots.
Ooh. What is that?
Shrimp.
It's a shrimp.
guy.
Yay. So we put that under art. Art for arthropod. Arthropoda is the phylum.
That's a beautiful
Okay,
focus, Dave.
It's really
Come wide,
pretty.
please.
Love it. And they're decapod,
It's
so
hard.
usually I do like art deck,
Yeah.
and then, but you could do art, it's fine.
I can make an adjustment.
Somebody said, I don't know if it was already asked while the live was down, but what was for dinner?
Well,
Now
let me
that
tell
some
you.
of the members are back.
I'm going to tell you all about the grilled cheese.
What wasn't for dinner?
Yeah, really. Pretty much everything is available.
We have buffets here on
Yeah.
board.
Yeah, lovely, lovely. I had grilled cheese, and I think they make it with maybe garlic bread, butter or something like that. Anyway, the crust, the bread is delicious. And I had grilled or boiled vegetables, I guess, and then I had some water. That was it.
Yeah, I had some beef curry,
Ooh,
some couscous, and some tomato salad.
nice.
So good.
Yum, yum.
I also tried the grilled cheese, but I had it with some of the shepherd's pie.
Ooh,
It was
that's
pretty good.
Huh.
And then I finished it off with a kiwi fruit.
I
Nice.
missed the kiwis today, but I've had 2 already, so I guess I didn't quite get there early enough. Kiwi fruit are precious commodities on board. First come,
Yep.
first serve. everyone is
1 minute there's
excited
10
about
and
them.
then the next
They
0.
disappear. Yeah, magic.
Same with tangerines.
Yeah,
They go
that's
very
right.
quickly.
That's right. Super juicy, unctuous loveliness.
I had an oatmeal and raisin cookie.
Oh,
Ooh, those are good.
They were very good.
Those were delicious.
Excellent word.
Has everyone gotten to eat dinner? In here?
Or we're making them really hungry if not.
Yeah. Somebody said incredibly long antenna on that shrimp. And why do seagulls fly over the sea?
Because they can.
They probably feed off of some of the creatures that live in the sea.
They do.
But we don't see many birds out here.
Well, we haven't. It's interesting. As soon as we got closer to land, like when we did the transfer at Aitutaki, we started to see more birds. And then they disappeared again.
Yep.
So.
Yeah, I've seen more flying fish than birds out here.
Oh, you've seen flying fish already?
Yeah, I've seen one. And I have seen maybe, I guess, one bird.
Oh.
So they equal out, but.
Ooh, yeah. Can we get a close-up on this?
Yeah, we'll zoom in, please.
I think someone said that this might be, this is a glass sponge. Might be Ferriidae. Ferriid. Really seems like there's been many of these throughout the dive.
Yeah.
Along with the tulip-shaped
Okay,
sponge, the Hyalonema.
It's tough.
And then I'm seeing a number of stalks, some sort of white stalk that's attached to the rocks.
Yeah, what are those?
Previous ones, the single stalk organism was at least one primnoid octa-coral, but sometimes they can be a type of sponge as well as they can be the stalk of a crinoid. So that's why the zooms are really helpful for us to differentiate one from another. We haven't seen any fish in a while. Interesting.
We have a couple of responses to why do seagulls fly over the sea.
Oh, wow. This is great.
Because roads are the territory of chickens. Because if they flew over the bay, they'd be bagels.
Oh my gosh.
Okay, that was pretty good. I like that.
I like it. Thanks everyone.
Keeping us entertained. We have a question. How often do you encounter animals and organisms that have not been discovered yet?
Oh, that's a great question. Oh, we just saw what looked like a salp house floating by. I'm going to speak in generalities. I feel like every time I use an ROV or a submersible human-occupied vehicle sub, any kind of exploration tool, I feel like we see something different or see something new, or extend our understanding of the ranges of different species that we find on the seafloor. That's what makes it so incredibly interesting. Can we zoom on the right? There's a sea star that I don't think we've seen before. It's white. Yeah. And so that's why these images are really incredibly helpful, because we're exploring a part of the seafloor that's never been imaged before. And we're collecting valuable data on the environment as well as these animals that we're encountering. And for some of the species, we may actually be able to further identify them based on the imagery alone, and then hopefully provide us with enough information to decide on what to do and where to come back to and focus our efforts. So we're right now looking at a sea star, Chinoderm.
Okay, we'll try and zoom in there.
type of asteroid, asteroidea. And take a zoom in. I swear I saw one that resembled this one earlier on the dive. It was on a boulder. And
Nice.
you can see its arms kind of coiled up a little bit.
Great zoom.
Lovely.
Thanks, guys.
Okay, I'll come wide, please.
We have a few folks at home who will be able to take that image and give us a better understanding of what kind of sea star that is.
Yeah, back to that question. I think Adam was saying, on average, about 10 new species per year are discovered on the seafloor.
Wow.
Rough estimate, but we have another question. What were those little yellow cubes that were sent overboard the other day? Thank you.
Oh, that's a good question. Do we have anyone here that wants to speak about the landers that we deployed? Oh, we deployed these devices called landers, like landers that we send out into space, like the lunar lander. These go to the deepest depths of the ocean. These ones were deployed to help us gather oceanographic information, environmental information on the abyssal environments that we're investigating here. And they're built in with a variety of different instruments and sensors to provide us that information over the next year or however long they're programmed for. And then at some point, they'll be released and brought back to the surface and retrieved. They have this device called an acoustic release. You basically send a sound, a ping down to the seafloor, and that tells the lander to drop its weight and come back home to the surface. And basically the ship that has sent down that signal will retrieve it at some point in the future. But those landers are really essential and landers that we've deployed in other places in the world provide us that long-term context to the environmental characteristics in and around the areas that we're studying. That long-term window of understanding and information fills us in on the time frame between our dives, between those snapshots in time when we come here to the seafloor. Looking forward to finding out more about the data that those landers gather when they get retrieved in the future.
Looks like a
Yeah, we'll zoom in,
like
please.
coral.
Yeah, can we zoom in on the what looks like a coral to me? Oh. Looks like a type of octa-coral with multiple branches.
Somebody commented, that camera is incredible.
Okay,
that's
we'll
amazing.
come wide, please.
Lovely. The polyps are oriented sort of down the branch, one adjacent to another. Their orientation and position on a branch is a really important characteristic for trying to identify what they are in terms of their genus and species, how they're oriented and their shape. And so the images will be really important for further identification.
Atalanta goes where it wants, and I follow. But yeah, definitely being pushed a little bit that way. Maybe there's a current.
Somebody said the lasers are back on.
Yeah, the lasers are back on. I guess they got fixed.
Little Heart fixed himself.
All right.
And that is a primnoid
Oh,
octa-coral.
another crinoid. Nice. Thank you. Thank you for the ID. We have a species guide from abyssal environments, basically images and IDs of organisms that have been collected in the area and other parts of the abyssal plain, and we're using that to help guide our understanding of what we're seeing in front of us, but we also have a number of experts who've been tuning in and staying up late, helping us out. Appreciate everyone's time. This is really a rare opportunity to work in these environments, and it's even more wonderful to have such help from the shore. I'm starting to wonder if we should take it for granted that the white branched corals are primnoids.
Oh, have a quick zoom and we can double check.
We should never make assumptions though, it's bad. Nice. This looks a lot like what we were seeing just a bit ago.
So we have a question. How does the microbiome of deep sea corals differ from those found on reefs?
Still trying to find that focus.
Yeah, and I
Thanks,
just,
Dave.
it's, once you get into that super zoom, it's,
Yeah.
it's just
It's a great
real tough
question
to
about
get it stable.
microbiomes. I think
Yep.
I'll say my expertise is not on the microbial ecology of corals, but I will say that from what I have learned from one of my colleagues at USGS, Dr. Chris Kellogg, she's been studying microbiomes of corals around the globe, and it seems like there's a lot of specificity. So within a coral, and corals right next to each other can have distinct microbiomes. Different species of corals, whether they're shallow or deep, have distinct microbiomes. So I think there's a lot of variation, and that microbiome helps keep the coral healthy in its functioning. So pretty amazing work. Understanding the microbiome of those corals in different environments gives us a window into how healthy their environment is, and also provides us with an understanding of how to help restore those environments, like in the Gulf. And so everyone is still learning more and more about the benefit of microbiome, whether within ourselves and humans to corals, and that translates to corals in shallow and deep environments.
Is there training you have to go through before boarding a ship? And if so, what kind? Does anyone in the front want to tackle this one?
Go for it, TJ. That's your question. What training do you need? Any specific training that you need to come work on a ship? Go on. Go on. TJ's a little shy, and he also doesn't know how to use the buttons. Just click one, and it'll
Probably
go up.
trouble with the microphone.
There you go. Unmute.
Thanks, Dave.
Oh, there we go. There's TJ.
There's no escaping. Oh, what was the question there again?
What's the, is there training you have to go through before boarding a ship? And if so, what kind?
Yeah, so you have your, as a crew member, you have your basic safety training. It's our STCW. So that would cover basic firefighting, life saving, and first aid. Yep, 2 seconds. And then as you progress with your career as a seafarer, you can choose to go through various departments. You can take on engineering, navigation. You can go up on the bridge and become a watch officer, do a cadetship. There's various different routes. You can go back to university, do marine science, nautical science, and come back and be an officer, do officer to watch, and then progress on to master mariner. Or you can do what I do, aspire to be like Josh.
Yeah, okay.
Every time we board the ship, we also get to experience safety drills, right? TJ, can you talk about that?
Yeah, so as part of SOLAS, every person on board the vessel has to know where all the safety equipment is, carry out various drills, and the crew would be involved in various drills throughout their period on board. There's a schedule of drills, whether it's firefighting and in various compartments on board the vessel. You will have confined space drills, obviously first aid, various different cases, whether you need to do a stretcher rescue. Often vessels work in conjunction with the Coast Guard and assist with Coast Guard training as well, whether it's helicopter rescue or transfer of a crew member from one vessel to another. I'll just leave you there now. I'm just going to do a handover here.
Thanks, TJ. Hit the mute. Yeah.
There's varying levels of training that that people can take. The STCW is the basic one, like TJ said, and that covers just a basic certification on firefighting and life saving and escape from the vessel, either through fire, smoke, wearing a smoke hood, that kind of stuff, and basic first aid, CPR, all that kind of stuff. I took a more advanced class called Beausiet, which does all of that, plus it's aimed at folks that are going out into the Gulf of Mexico on oil platforms and that kind of stuff. So it involves helicopter rescue and that kind of stuff, plus escaping from a helicopter, which was kind of interesting. They have a helicopter mock-up that they strap you into, and then they drop it into a pool, and you have to escape from that. That was...
Escaping from a helicopter.
Yeah,
I don't know.
I know.
That sounds very thrilling to
Yeah,
me.
I know 5 different ways.
You have to do it in like a pool, I
Yes,
guess? They drop you in a pool?
In a pool. They have a mock-up helicopter fuselage. They strap you into seats. You strap yourself into seats with a 5-point harness. And then I know 5 different ways to escape from a helicopter.
Wow.
Whoa.
The first one's easy. You just pop the restraining belts and pull yourself out of the window.
Upside down or right side up?
Both.
Oh, goodness.
Yeah. The next one, they put the window. They actually put the window in, so that you have to pull the exit.
Coming up pretty good.
And pop the window out, and then roll yourself out.
Can you
and
turn your head?
Once they do that, then once you
20,
do that
20
successfully, then they turn it upside down.
20 degrees to port.
And then how to use a life jacket, inflatable life jacket. Actually drop into the pool and then pop the inflatable life jacket. And how to swim with it.
Maybe when you get your chance, can you go through the log?
And
fill out the log.
And then actually inflating a life raft and climbing into it, which is not as easy as you might think, especially when you've got an inflated life vest on as well. So it's all practical experience and that kind of stuff. It's good knowledge to have, good experience to have.
Oh, for sure. Also helps you learn how to stay calm in a really stressful situation.
Yeah, that's the biggest thing, is that you're experienced with what this is like and how it feels. It's always different when it's for real. And but it at least gives you the knowledge of that you can, if you follow these procedures, they've been proven to work, and it's going to be your best chance if you have to actually escape from a vessel.
Nav, approximately how far are we from waypoint 2?
Yeah, give me 1 second and I'll check.
Which is it looks like the waypoint 2 is sort of the top of this, or the middle of this dimple shape in the feature of the knoll.
We're about 300 meters.
About 300 meters?
Yep.
Okay. Thanks, Nav.
Things look pretty consistent there on the log, Ryan. Oh, that's okay.
So based on the contours, Jacob, does it look like we're going to continue to help
Just
head
like
upslope
and stuff.
to that
coming up on the
waypoint?
winch a little bit.
Yeah, so the plan right now is we're going to go to the pinnacle of this seamount, and then we're just going to kind of stay on station and do maybe like a 360 around the whole thing.
Ooh. Okay.
And then when we're done, we're going to go out into blue water, and then we're going to descend into one of these, John was calling them donuts. But they're basically these like volcanoes with these depressions inside, I guess called eras. And then we're gonna just descend right into one and then go up one of the sides.
Donuts, dimples, so many different ways to say the same thing.
Yeah, there's a bunch of ways. He called the flat ones pancakes. So.
I like pancakes too.
Can you see if somebody wrote down in the book there that the gauge on Atalanta is loose in the mouth there? Did anybody write that down?
Oh, I see it. Yeah, right there.
Ooh.
Stir.
Yes. Looks like another, maybe a rescinded sea star.
Zoom in, please.
Just hanging out
Oh,
on
wow.
the edge of a rock.
It's got skinny arms.
So pretty. So in the previous expedition to the Cook Islands, they've collected one
Wide, please.
Friella?
Friella, yeah.
Friella, which is a type of rescinded. I can't verify if that's the same as this one, but they're known to occur in this region. In places where I've seen rescinded sea stars before, they often are on the tops of rocks or perched in such a way that their arms can essentially wave, be able to capture particles flying past them, and then those particles serve as their food. Looks like we're coming upon another sponge that looks like a tulip. I've just been seeing these quite frequently on this dive. And then the terrain has really changed to some smooth rock with a lot of debris, maybe that's coming down slope. and some exposed sediment.
Ooh.
Looks like another branched coral. And there's some people just joining us now on this dive. Again, we're exploring part of the seafloor that's never been visualized before, making discoveries along the way. And in terms of animal encounters, we've seen a variety of different sponges, echinoderms, including asteroid sea stars and crinoids. We've seen a variety of different fish and corals, and I think some people have really been excited about the really pretty ctenophore that we encountered. We saw some other types of jellies, medusiform. And then, what am I missing? Mikhail, do you remember anything else?
I don't know, a lot of poop. I'd say a lot of poop.
Sea cucumbers and their poop.
Yep.
Thank you. How could I forget? What's that shadow down? Oh no, sorry, it's a rock. It's one of those rock fauna shadows again. Yep, lots of sea cucumbers and their poop.
This is a good spot. I mean, it's on a slope, so you're gonna have a lot higher altitude, but the delta could be lower.
When we say we saw sponges, there are a variety of different kinds of glass sponges, as well as carnivorous sponges.
Big slope, right?
So even within each group, we saw a variety of different taxa, and hopefully some of the images will provide us with a better understanding of at least the overall diversity of this area.
So really
images will provide us with some additional details,
in this nice
and
area, then
our experts on shore can review them, and give us an idea of who we're seeing. Maybe we'll get some feedback before our next dive, and we can use that information to make better identifications on these dives. We'll see, but it's been pretty incredible so far.
Tulip sponge.
Yeah, another one. A few of them. Definitely a type of sponge that I remember seeing on our seamounts on the New England side and other parts of the Pacific as well. Probably a different species, but the sponge is pretty typical. Looks like another branched coral. Pilot, do you have an idea of what the bottom temperature is here?
Yes. Can you go to this dashboard here, and then choose, no, where's the little Herc one? Oh, sorry, go to little Herc Grafana. And then scroll down. Is that it? I'll get back to you on that.
That's great. Future homework.
We are at least at about 4,000 meters.
Yeah.
in depth?
Yeah, we've climbed about
over to
what,
that.
500 meters.
At least, yeah.
Yeah.
And then
We went to sleep
choose-
before
get rid of
the
that.
ROV
That's-
reached the bottom today, so. This dive has been a little more eventful.
Sure. I can try.
Well, just go back to the
So
other
we have
one.
a
I'll
question
figure
of
it out
why
later.
do nodules exist in abundance in some places, but they're scarce in others? What do you think, Rima?
Well, firstly, you can kind of find them
Yeah.
all over the world,
Stop for a sec.
but it's when you
to-
get them in those really deeper, flat abyssal regions where you find them
be
in
a
high
another little
abundance,
herd to put
and
down.
you find them in with the concentrations
Yeah,
of
go to that
metal
one.
that you're really interested in. So here in the Cook Islands, we have quite deep abyssal plains down to 5,000 meters. But we also have a raised plateau in the north,
Go down a little bit.
and some historical cruisers have actually found that even though the plateau is only 3,000 meters deep, we're still finding those nodules there.
About 2 degrees.
Not in that much of an abundance,
So
but
now go back to the
and
little herd
not
pilot.
with the concentrations of metals that we find in our deeper regions. But I think it has something to do with being in the deeper regions where the currents are quite slow, the sedimentation rates are quite low as well, because these nodules take millions of years to form. So you kind of need those kinds of environments for them to be able to form in large abundances, I guess. But yeah, good question. I think if we had some of our geologists in the van, they might be able to give you a clearer picture. But yeah, that's what I've sort of found here in the Cooks.
That's good.
We got a reading on that bottom temperature. It's just a little less than 2 degrees.
Water temperature a little less than 2 degrees. Is that what I heard?
It was about 2 degrees, yeah,
About 2
from the
degrees.
CTD.
Yeah, thanks so much. 2 degrees centigrade. That's chilly.
Yeah.
I sure wouldn't want to live down in these regions
Need a lot
the
of
world.
layers. And a pressurized chamber.
Not only is it really cold, but there's not a lot of food there, so
True.
You get hungry fast. Maybe we could get Gail to send us a care package of food. Afternoon snacks. Delivered by the ROV.
And then the occasional whale fall.
Ooh, that's scrumptious.
I'm
want,
scared of the dark too.
Back in.
So
You might have to bring a flashlight then.
Oh, holothurian.
I'm happy to.
where do you see it?
Oh, it was in the bottom left.
Oh, okay.
And we missed it.
Did you happen to go in there? No, okay. I can go do a little walk around if you want to jump in here. Things seem.
What is the point of the laser?
That's a good question. These lasers are giving us a sense of scale. They are 10 centimeters apart. So not only can they help us give us an idea of the size of organisms that we're encountering, but they also are giving us an understanding of size of the rocks and the seafloor features. So we can't take a measuring stick with us, but this is our best way to measure scale. And when people are annotating the video, they are able to essentially size class organisms when they're tracking each of the different animals that we encounter throughout the dives. And and gives us an idea of size and distribution of species.
Yeah, it might look like they're converging to a single point almost, like towards the center of the frame, but they're actually perfectly parallel with each other. So it's just because of the wide field of view of the camera, it kind of looks like they're pointing inward a little bit, but yeah, they're nice and parallel. So
We believe you.
If you say so.
We know that they're calibrated and balanced before each dive.
It's quite a creative way to measure space.
Yeah. It's so essential. We do turn them off when we want to do really nice highlight videos of certain organisms or seafloor texture or whatever, but they're essential for scale. So keep them on for most of the dive, especially when we're doing these kinds of transects from one point to another.
We have another question of what is the average dive time for an ROV, and what is the deepest any kind of model of an ROV could go? So the deepest Hercules can go is 6,000 meters.
Yeah, little Herc can go down to 6.
And then, oh yeah, little Herc can go down to 6.
Yeah.
Big Herc can go down to 4,000 meters.
Right.
And the average time for an ROV, I know our dives are about 24 hours, but I don't know what the average
Yeah,
time
they're
is.
basically, it can be unlimited. We've had dives that have been multiple days in length before because the watches are 24-hour watches. They have people cycling in and out either on 12 or 4-hour time scales. So as long as the food doesn't run out, we can stay out and stay down for as long as necessary. Sometimes the limiting step for us is if we're collecting specimens, like with the big Herc, we might fill up the basket, collect a bunch of samples, and those need to be processed in a timely manner. And so we want to bring Herc back on deck to ensure that they get processed. But other than that, you could stay under for quite some time. And in some cases, you want to do that so you can get a good understanding of temporal signals.
So little Herc might have a longer dive time.
Yeah, I think the tentative plan was for a 24-hour dive today, but I don't know if that's changed or if we're kind of rolling with it. But since everything is going really well and we're making great observations along the way, I think I will keep Herc busy. It's incredible view from Atalanta. You get, it's really like a bird's eye view, I guess, or overlook of where little Herc is ascending. And you can see this vast seafloor, hard substrate around us as we're heading up slope. Quite magnificent.
I wonder if any of the ROV people in the room know.
So a holothurian?
Yep.
Oh,
yeah.
Purple sea cucumber.
There you go. Purple.
Can we zoom on the sea cucumber, please, pilot?
Yeah,
When you
ready
have
for
a
zoom.
chance?
Dave, you can zoom if you like.
I think someone said that this might be Benthodites. I'll have to look up my sea cucumbers to get a better understanding of how to differentiate them. Remind myself about their different morphologies.
Ooh.
Ooh.
So crisp. Wow.
Nice. Super purple.
It's a big one.
Oh,
Little,
nice.
sorry, just stepped in the seat.
That's good. You're good. Thank you so much. One thing that we can't see,
Thanks, Dave.
because we don't have our microscope camera on board, is there are a lot of different organisms that are living in the nooks and crannies of these rocks that we see in front of us, in the sediments. These are called infauna. And someone was tuning in earlier when John was talking about the different size classes of animals. We find microfauna, myofauna, and macrofauna within the sediments. And those animals are food for other critters. They also play an important role in processing that organic matter that we see raining out from the water column. They keep the ocean environment healthy. So they're an important part of the cycle of life here in the deep sea and in the water column. And for my research, we often bring push cores, core collecting devices, to collect sediments from these areas to better understand those communities. And they're an important part of the diversity of these seafloor habitats. All right, so I'd never seen a shark tooth on the seafloor before. Was there a first for you on this dive, Kahena?
Have we seen shark? Well, this is my first dive ever.
First dive ever, yeah?
So
So everything's new. Anything that you were super excited to see?
Some of the starfish have been pretty cool.
Oh, all right.
In my opinion.
All right.
Yeah.
They are cool.
And the succulents.
Which ones?
What do you call them?
Hollothurians? Sea cucumbers?
No. The big white ones? Anemones, the anemones, that's what I meant to say.
Those have been pretty cool.
Yeah.
Yeah.
Massive. Did you get to see any of them? I know you were at dinner.
I think I was at dinner.
Yeah.
I missed it.
We saw 2.
Ooh. Oh, wow.
You missed both of them.
Man, well, everyone has to eat sometime. Did you guys get any ideas on what they might be, or no? Any help from shore?
Nope.
No, okay. Next time I'll phone a friend, see if we can get some IDs. How about you, Rima? What have you been most thrilled about seeing? I know sponges are high on the list.
I know I keep going on about the sea cucumbers, but they look pretty cool down here because they're like translucent and with those reddish edges, they look pretty cool. And the disco looking one was pretty cool. What was that one called again?
The ctenophore, the comb jelly?
Yes.
Because it had
like
those tines,
lights.
and they were like, yeah, it was iridescent, right?
Yeah.
Just this disco ball in the deep sea. Yeah.
Yeah, it was
dancing
pretty cool.
to its own tune.
This is also the first time I've seen a live dive, so I've seen everything for the first time.
Oh. Wow, this is really a special day.
Oh, what is that? An octopus!
What?
Yes!
Oh, yeah, did I just have to say that out loud?
Sorry, guys.
Sorry for the loud noise
goodness.
in the background.
What does that go under?
You have to do other.
Okay.
You can zoom when you're ready.
I was
to.
hoping to see one
MOL.
today.
I'll try.
I know there's boulders all around, but go as close as you're comfortable.
And
Going
then you can
before
put
we zoom,
octopus.
that'll help us
Okay.
out with light and
Right.
angle. And he's coming towards us, so it's even better.
Cool.
Oh my goodness.
Okay, you can
Good.
zoom
Yep.
there, and I'll try and.
I think eventually we want to
We'll do. If you
stow
can just
the
keep him center of frame.
lasers after we get a scale.
No worries.
Sorry, I got auto altitude on there. I'll turn that off.
Here it comes into frame. Very good.
Whoa.
Can we turn the lasers off, possibly? Sorry to make you do 5 things at once.
Thank you.
Thank you.
I take my.
Ooh.
It's great, great imagery. I know that people who study octopuses are interested in looking at the arms and the orientation of the different suckers that are on the arms.
Coming down to see
really
Florian.
what a treat. So if this octopus is down there, this is obviously enough food for it to make a living off of.
Oh, can you zoom out again?
I think I know where all the hollothurians went.
Oh, it's Friday. It's Friday on the East Coast.
And it was World Octopus Day
Octopus
yesterday.
Friday.
Oh, yeah? Oh.
Wow, it's so beautiful.
Somebody said
Okay,
that's very likely a new species. What do you think of that?
I would love to learn more, for sure.
That is amazing.
We have a colleague, Mike Vecchione from the Smithsonian, who's done a lot of octopus IDs for us in the past.
I'm going to have to move.
Cephalopod IDs in general. He's been an incredible resource. I'm sure many others can provide some insight.
That was great work on the ROV piloting
Nice
team.
job.
So
yeah.
good,
well
yeah.
It was quite a
Well done.
choreography.
Did we mark highlights on that?
Oh, yes. We
Oh,
should have.
mark highlights on that?
Yeah,
Very good, thank you.
I did.
When you're ready, we can have the lasers back on, please. Unless you see another octopus. Thank you.
Do the lasers mess with them? Is that why you want the lasers off with the octopus?
The lasers are great for scale. They're not so lovely for highlight videos. So if we want to kind of take away that interference and get a clean image, the lasers being off are better. But sometimes it's unavoidable, it's okay. But for pretty imagery, for a really nice video, not having the lasers on is good.
Yeah, just curious. Thanks for letting me know.
Good question. Well, that was a highlight. Shark's tooth and octopus. That's nice.
I was really hoping to see an octopus.
You were?
I was.
Oh, there you go. Now you can go to bed. Well, not yet. You have an hour and a half.
What's that?
I keep thinking I see something, but it's essentially a crack in the surface.
Yeah, same.
So it's like a mirage. What about you, Mikhail? Any surprises, any highlights for you on this dive so far?
Well, I think the octopus was, like, that's at the top of the list right now for me,
Okay.
for sure. But yeah, anything dynamic and that swims is really interesting to look at, I think.
Yeah.
Not only because it looks cool and pretty, but also because it's a challenge to capture that motion and like a cinematic way. So it's both a challenge for the ROV pilot as well as, you know, the video engineer. So it's very rewarding when we get a nice capture like that.
Yeah, Tim did a really good job, and I was able to actually hold focus on it most of the time.
Yeah, you all make it look so easy. I feel like sometimes as a scientist, I take that for granted. It takes a lot of effort and coordination to pull it all together.
Anybody watching online, they're missing the motion of the vessel that we're rocking with too, so that throws another
dimension,
another
right?
element into
That's
it.
for
Yep.
sure, for sure. Rocking and rolling.
Rima. What were you going to say? I was just going to say, where did everything go?
The octopus got to it.
I
Yeah,
guess so.
I think so.
Had a little lunch before we came by. Now we can't find anything. What were you going to say?
Oh, I was going to ask you, considering you work in the region, what were you expecting to see and what has surprised you? Is that something? No, that's just a rock. Okay.
Yeah, it is
Actually, I
kind
think
of obscuring. It's funny that it looks like it.
the octopus was probably the biggest surprise. I actually didn't think we'd see it down this deep. So yeah, it was really cool. Otherwise, everything else that we've seen so far, I've been able to find in this APSMA catalog. So
Yeah. What does APSMA stand for? Abyssal?
Pacific Seafloor Image-Based Megafauna Catalog.
Ooh, that's a special volume for megafauna invertebrates that have been ID'd so far.
Yeah, shout out to Eric Simon Leto and your crew.
Yeah. Incredible resource for sure.
So yeah, it's really exciting to be having these dives and sort of create a custom catalog for the Cook Islands one day, I guess. Oh, is that a branched coral of some sort?
ROV, can we zoom in on the coral?
Yes.
You never get enough corals around here.
I'll just get up a little bit closer to it.
Okay.
There you go, Dave, whenever you're ready.
So this is a branching type of octa-coral.
So clear.
Yeah.
It's crisp.
Oh, interesting.
I'm
The
losing
bed
it there.
forms in the sediment. You can see the waves in the sediment. That's cool. That's great. Wow. The sort of ripples, sort of, you can see those on the beach too. Ripples in the sand.
Yeah. Lisa mentioned it would be cool if that octopus is one of the Casper ones. The ghost octopus.
Ghost awesome.
Would you need to like see its face front on to be able to ID it, or is the from above good enough?
It's a good question. I'm hoping that we get some more guidance from our octopus friends at home.
I took about 20 screen grabs.
Yeah.
Good.
Like I mentioned that I know tentacle or suction orientation and number sometimes play a role in identification.
Never mind.
But beyond that, oh yeah.
The branched coral
There's
again.
a branch coral on the left, Pilot. On the boulder at the base, yeah.
Somebody mentioned likely another primnoid unless you saw any obvious nodes, but the polyps?
Yeah.
The polyps and Warris.
Whirls?
Whirls?
Yeah, got a lot of...
is a trait.
Yeah. Is a trait, okay. Yeah, well, what's wonderful about the cameras, the video, we'll be able to scrutinize some screen captures afterwards, which will be important for better identification. I kind of wonder if we're seeing something attached to this coral, like an associate.
You can zoom there, Dave, if you want.
Oh, maybe it's just something's colonized the bare tip of it.
I don't want to hit the camera into the rock. A little close there.
Yeah, so I'm not a coral taxonomist, but what I do understand is that, you know, the orientation of the polyps around a branch, around the axis, in the case of whether or not it's an octa-coral is determined by the number of tentacles within the polyp. And then crinoids, I mentioned this before, but they have this sort of characteristic scaly type feature on the polyps themselves, and all are oriented in a certain way around the axis. A lot of different features. Hollothurian on the right. Oh, what's that white object on the left? I don't know.
Are the organisms with eyes affected by the light of the ROV? That has to be the brightest thing they've ever seen, from Nick from Massachusetts. It's a good question.
That's a good question. Some of the fish that we've encountered on this dive are known to be blind. Their eyes have basically been overgrown by tissue, and they retain the eyes, but they're called vestigial organs, essentially. They're no longer of use to the animal. So they have no real need for their eyes in a major sensory way. They may sense movement and changes in other ways. So good question regarding eyes. There's some organisms that are adapted to really low light environments and have evolved to have really great sensory capacity to note changes in light.
I'd say that probably motion and vibration more affect them than light does. Though we do see occasionally, we see animals, fish especially, that shy away from the light.
We've definitely seen congregations of organisms accumulate when the lights are on. So
yeah.
I know we've had interference with a variety of different fish and squid and zooplankton that have been attracted to the lights. So much so that you can't even see in front of you. So you have to keep moving around, moving the ROV around to get away from them. So yeah. It goes along.
The ROV makes a lot of motion in the water, which could be perceived as a large predator by some animals.
Yep.
It also creates vibration. It has a large hydraulic pump that's running, making a lot of noise, and that kind of stuff as well.